How you doing? How you doing? Just waiting for somebody to pop in, and someone just popped in. I want to talk about and this video I'll leave up, anchoring epoxy and what can be used for different situations. Rick out in, Rick is in Texas. He's got some brick that are, well, this might not be the best solution for it, but it is a solution. He needs to resolve why I did it at first. But this is an anchoring epoxy. This was set, let me see what time it is now. It's 7 o'clock. Let me get my timeline. This is 4-hour epoxy at 7,000 psi. It's a Quikrete product, and I normally don't do, so I'm not endorsing them, but I am endorsing them, right? So they didn't give me this product for free, although a few companies have. This one, this is an interesting product. This is now over a year old. I have a case of it still, and it's working great. With that said, here's just 2 pieces of stone. As I was, let me lower this camera. And don't be afraid to ask a question about this epoxy as I'm doing it. And hello to you 3 people there now. What I did was you can clearly see, hopefully, yes, that you have a spot there and a spot there. So all I did was pour. All I did was use a caulk gun and put a dab on it here and here. And 0 preparation for these bricks. And we're going to try to take them to failure. But 0 preparation. And this was done early today. And just those 2 dabs, if you can see them again, here and here. Then it was just a dab here and press the 2 together and walk away. Interesting, I'm experimenting with some metal connections with the epoxies. That's galvanized, obviously. It saved me from welding. It's kind of an interesting tool I'm going to make. I got it from the idea from these guys from Vietnam that have tools there that we don't have here. What they do is they have 2 pipes and one pipe, and I get to choose still. One pipe is the pipe you hold. The other pipe, hey Hermit, cool, hello Hermit. So when we start over, I'll start over, but this is just talking about epoxies, and hopefully Rick will use this at his property for his repair when I'm done. Rick is in one of our viewers like you, Hermit. It's only $20 and it gives you a long stretch. But let's just, right here, all I did was lay a bead down on the face of this. I did lay a bead on the top of the pipe and then put it together as it was laid onto the steel bench. I then ran an additional bead down the top. So you could say this is a first surface bond here and an additional bond there. Now I'm going to try to make this fail by just how you would typically use it by hand, not by, I'm not going to put a pry bar in there because that's not what would happen typically, right? Hey, glad to be here. Hey John, glad to be here, John. Glad to be here, John. Yep. Hermit. Justin, John. Hey John. So I guess that's your name, Justin John. Got it. So now, that's the epoxy. It's only $20. I'm trying to talk him into using it. Here's our 3 samples or 4 samples we have here. Let's go ahead and bang at this. This might be a little loud in your ear, but I'm going to bang it onto this, which actually only has, this piece of steel here, only has, and this might fail, only has a bead on each side of it. It does not have a, hey Doss, I could have used some epoxy in Florida, yeah. So, yeah, so this only has a bead on each side. I'm curious, this piece of steel is pretty damn heavy, so I'm curious if it will rip away, especially with the fulcrum I have going on. So let's see what happens. So far it's dragging pretty, it's dragging, and I'm taking shots in the video for you guys while I turn it up. So just turn it up, and you can see that only the bead, you see that small bead? Laugh out loud, Hermit. Fill in the cracks, yeah. It's only a small bead here and a small bead on each side. And this has only been in there for about, I don't know, 7 hours. Just about, no. It might have been closer to 11 o'clock when I put this together. I'm not sure what time you guys, we hit downtown. Hit down there. Well, look, let's just go ahead and pound at this a little bit. Give it some different torques. See what some reactions. It broke free. Okay, so that's done. There's the bond on it. Oh, no. So there's different, this is good to talk to you about different failures. So this is how you would look at a failure for flooring materials. So this is going to help out. And so it didn't fail. The epoxy did not fail. And what failed was the metal. It took off the entire, the galvanized. The galvanized failed and not the epoxy. So this is kind of a cool dual video. I guess I should retitle it maybe. This is actually how you could, when you're evaluating materials, what you're looking for. You see the epoxy still bonded. This is the shape of the galvanized pipe. It's not, we're not looking at, literally, we're not looking at epoxy on this. This is the epoxy. That's the product that came off. The coating failed. So very, very interesting. So let's take this pry bar to it. What did we get? Zinc peeled off? I don't think so. You know, this pipe is, it looks like it might be some type of, because you see this raggedy edge? Let's see if I can get you in the video. Oops. Looks like maybe it's some type of gray paint or something that might have been on here. That I guess I should have used a different pipe now. Now I'm wondering about my other pipe. But let's go ahead and hit this now and see if we can get it to shear off. So we did get it to pop off. So the epoxy did pop off of the face of that. And we look at the underside and we do the same thing. Or you guys, sorry. Now we do the same thing. And we evaluate it. I'm looking at it to see if this came with it, or did the epoxy just break free. And that's going to tell you your bond. Let me make sure that you guys are, yeah. And I'm leaning towards, nope, it's part of material also. See that thin layer? Get it under my nails, it'd probably hurt. It's a very thin, wait, let me verify that. I'm looking in the camera now too for you guys. No, I'm thinking it's all epoxy. Can't really tell what I'm very, that's just the texture of the metal. That one might require me to go take it inside and never gonna break that. I mean, they are brittle. Epoxies are. And we'll get to the brick in a minute. But not this piece of epoxy, huh? Just trying to take it. Let me make sure you guys are in the camera. Take a look at it. No, so I say the bond broke off of that, and I don't know what forces it were. If we had a real tool to pull it on, it would be really nice. But that was specifically one spot. That was a lot of load off of, dialed in, and I don't know what that would equal. That could be as much as 1,000 pounds, believe it or not, per square inch that I just put on it. So now we're back to let's jump on the brick. The stone, these are just two pieces of stone that I just put together, didn't care, didn't prep it, just dabbed it and pushed them together. Now let's see what happens when we go at the epoxy stone. So just in general, I'm just, you know, I'm trying to break it with just shear action and not going nowhere with that. Now, of course, I can break the brick, so we want to test the bond. If I tap on this, I'm going to break the stone rather pretty easily. I want to get the shearing action of these two away from each other, and I don't think I can do it. Let's try prying away. Nothing. Nothing. And that was probably close to 400 that way, probably 800 pounds of force on it. 400 each way. Remember how you have those tools that test my, I can put 300 pounds on one finger alone. You remember when I showed you on the other tool. So let's try that again. Put that in my palm there. Push and pull. I mean, I'm going nowhere. I'm going nowhere with just a dab. Now that's your epoxies. Now it's $20 a hit. And once you use a tube, you're done unless you have an extra tip. The tip would be these guys. Now I do have extra tips. They're $1 each. Hard to find, but you take this off and you put the head back on these guys. This is still soft. They're two different, since they're not together yet. They're two different materials, so they will not. You can still use it. It's a mixing cartridge. Now, if you can look down that tube, I did a video and I never posted it, but this is probably right about there. You're not getting a full tube worth. You're getting 8.6 ounces. So don't get psyched up that you got a whole tube and think of it as a caulk tube. This is not, let me zoom out. This is not a caulk tube worth of it. Sorry about missing the comments. Paint, Herman, oh God, yeah. Aluminum paint. Huh, I don't know, Herman. It's a product I don't know where I got it from. All right, so now we got the bricks. Let's move this out of the way. This won't be that easy. Ah. Now we're going to drop these bricks a few times to see if we can get the shearing action going on their own. The shear, the break, the bond of these two. I don't want to, you know, I don't want to break the brick. So, that's it. I'm just hitting the one as you see, so I'm creating a shearing action every time. I just hitting this one here and holding the other one. So the ground, it's only hitting this one. Let me see if you can see it. The brick is also sharp. And I've already made a mistake of damaging this finger right here, this finger that I'm touching. I'm supposed to have it in a cast and go get this bone taken care of, but okay. Man, that is not going anywhere. So you can see just 2 dabs of epoxy is badass. It's 7,000 psi per square inch. I probably have almost 2 inches on that. And let's try the other direction, the other one, and see what happens. I've got nowhere near a break, or break a bond, if you will. Thanks. 8 ounces, maybe 4 ounces each resin and hardener. That's correct, John. John, I think that's your name now. I got it. Ooh, a bee. I could kill this bee. It's over here getting back on the bee that got me yesterday. I don't think it works that way. But, hey, you know, this bee looks like he's going to light me up, right? But I got to do my amygdala thing, right? So will a bee fear me? Or will it, it's over by that rock. Will I create fear in the bee that he stings me? Let's see. Nope. I don't know. I bet the epoxy could have kept that walking bridge from, you know, you'd be surprised. I mean, 7,000, right? It's 8,500 psi concrete. You know, epoxy could have put it back to where it's positioned as far as its psi. I mean, I don't know. Let me correct that. You'd have to make a sample, then test it after you fixed an epoxy test sample. And I don't know how many people have done that report. And that would be interesting. And it also had to be that type of system that you're checking under, you know, post-tension, that area, that forces. And that bond, you want to see if it bonds. Look, he's just rolling over. My man's on his way out. He's on his way out. Did you guys